Hello and welcome everyone at the Z Nights February edition, which is about a new beginning. Our very first presenter is going to be Oresztesz Margaritisz, head of the Budapest Java community, and he's going to deliver a very hands-on, very practical, sorry, a very practical session about TDD. So let's give the word to him.
Thank you, Esther, for the kind introduction. So hello, everybody. Yes, this is going to be a practical TDD session, which is entitled as Protect Your Invariant. And in this TDD session, we are going to do lots of coding. For this, of course, we need first an exercise. So what we will do today is actually we are going to build up a scoring evaluation for a bowling game. Maybe not all of you are familiar with the rules of this how scoring works in a general bowling game, because maybe it's not so popular in your area. So just let's go through these very quickly. So actually, what you can find on the screen is the bowling rules and mostly the scoring rules. So each game consists 10 frames, and in each frame the player has 2 rows actually to knock down these 10 pins that were set up in the bowling itself. And the score of the frame is the total number of pins knocked down plus some kind of bonuses for so-called strikes and spares. These are special kind of occasions when you were scoring very well and you receive some extra points. So the rule for spare is that when the player knocks down actually all the 10 pins in two rows in the existing frame, then you have a bonus that's the number of pins knocked down by the next row. And the strike is the same, but now you knock down all 10 pins in the first row, and then the bonus is that the value of the next 2 rows. So this can be quite dry, I know. So let's go through these kind of rules just very quickly in a real example. So what you can see on the screen is an actual score sheet. And what you can see here is that how the game was built up. So we have 10 frames in total. So each of these big boxes will represent a frame. And we have 10 of them, of course. Then you can see actually that in each frame you can have 2 tries, and in each trial you have the maximum score of 10 because you have the maximum amount of 10 pins. So here I just hit down 1 pin in the first round and 4 pin in the second round, gives me the total number for the score of the first frame, which is 5. And then I go to the next frame. I have the total score of 9 here. So this will give me 5 plus 9, so the total score of 14, and so on and so forth. But we have some kind of special notation here. First of that is that this kind of half full box or a triangle, which shows that I had a spare. So when you have a spare, you actually knock down all 10 pins in that given frame. So in this frame, this is the score of 4, but it's hidden. So instead of putting 4 here in the score sheet, you just mark it like that. And then now you have a bonus now. And the bonus is actually the score of the next row, which is 5. So that's why I don't have the score of 14 plus 10, which will be 24 here. I have a bonus of 5, so that adds up as 29. I hope you can follow me. And also there is another special notation you have to know before we start coding. This is a strike. So this means that now I had knocked down all 10 pins actually in the first round. And now I have the bonus of the next 2 rows. So this will give me the bonus of 1. So instead of having 10 added to 49, I have 1 additional bonus, so it gives me back the total score of 60. So 60 will be 49 plus 10 plus this 1 here. 10th frame is quite special. In the 10th frame, you have actually 3 trials at total. but you can take extra tries only if you have a strike or a spare. So if you have a spare, like in this case, this means that here I just hit down 8 pins, but it's invisible. Then I have the extra score of 6 because that was the score of the last round. I can take only this turn if I have a spare or a strike. So the maximum, actually the maximum score that you can have in the 10th frame is 30 because you can knock down 10 pins because you had a strike. Then you have 2 additional rows to go. So you have additional 10 and additional 10 at the end. That means that the maximum number of score I have here in the 10th frame is 30. Actually, I can score 30 all the way in all frames, and that gives me back the total maximum amount of score I can have, which is going to be 300. But let's now talk about the concrete implementation of how we are going to implement this. So you might think that the ideal representation of this notation is actually can be an array. So each of these small boxes can be represented one by one by an index-only array. But the problem is that you will have some empty spaces like here or here where you had strikes. And then you have to jump over those empty spaces when you need to evaluate invariants. Because this talk is entitled as Protect Your Invariants. Let's talk about the hidden invariants of the bowling game. So of course you have like 10 pins that you can score at maximum here in each frame. After you go to the next frame, again, all these pins will be reset in the floor and you start over from the beginning. And there are other specialties, for instance, here in the 10th frame, for instance, in other areas of the game itself. If you want to map this to this kind of mapping to array into the array, then for instance, this kind of first invariant has to be evaluated on each second index of the array itself. So for instance, from here to here, from here to here, this might be quite difficult to represent in a clean way in your code. Another alternative would be to have a various length of an array. But again, here you will have some kind of strange mapping. Like for instance, this 0 should be mapped because you have an empty space here. It should be mapped one index above. And again, these invariants will be quite difficult to keep up with this array representation. So yeah, let's go through the invariants in the next step. So as I said, you have the maximum number of 10 pins physically in the floor, which you can knock down in each frame. Then the 10th frame is quite special. You have either 2 or 3 rows, and the sum of rows should be at maximum of 10 on each frame. And the 10th frame is somewhat special because you can see that in here in the 10th frame I have 10, 10, and another 10. So here this rule is not going to apply. And as I said, this is actually the first sentence of the rule evaluation. So the maximum number of the frames is also 10. This is also actually an invariant. So where we should put these invariants, that's going to be the next thing that we need to discuss. So if you think about something like a model view controller, or if you try to slice up your application architecture in different layers, you can distinguish between something like a domain layer, an application layer, and a UI layer. So where should this logic go? This should not go, of course, to the UI layer, because in that case, you will end up with something like a smart UI, or you don't want to do this kind of evaluation of client side, because then it's hard to keep control over that. So you could put this kind of logic into the entry point in the first phase when the request comes in. This, of course, will protect the application from the boundaries. So everything that gets to the inner layers will be already validated. It sounds a bit logical, but this will bring you some kind of unwanted dependencies. Like your model either should depend on some logic in your controller, or maybe on some parts of your framework. Or the other option that you have is that you could actually have an interface over your model, but in this case, again, you need to have a dependency if you want to keep this logic in the application boundary. So if you want to avoid all these dependencies going back and forth through the different layers, what you can do is just simply encapsulate them into your model. And that's what I'm going to represent next. So let's see something that's going to represent the problem in simple objects. So you have, as you can see here, a game which has 10 frames. So first invariant is already included. Then there will be some special frames, one special frame actually, which is going to be the 10th frame here, which will have special rules. And then you will have some intermediate frames that will be the 9 frame preceding the 10th frame. And you can see now a clear mapping of the invariants themselves. So some of them will point to the intermediate frame, some of them will point to the 10th frame, but looks like game just holds one of them. So if you want to actually represent all of them in your code, it will be very hard to include each and every one of these in just the game class. It will be overwhelmed with different kind of logic. Okay, so let's go back to the rules and actually let's start coding as the next step. So what you can see here is that in the requirements, I also said define the interface. So you roll by defining the number of pins that actually you hit down, and then you have the score evaluation. So that gives you the actual interface of the game class. And you might really start with something that as simple as it is if you are doing TDD, which I show you on the screen. So I have an integer array here, but you can see now first problem, it's almost obvious that, okay, I have something here that looks like a magic number. Tells me I have 21 rows, but nothing talks really about frames. And I don't see the representation of the first sentence, which is, the game consists of 10 frames. So it's really hard to represent the actual way of the game structure, the requirements themselves, if we code like that. So let's see how far we can go with the code. I had to make some preparations, of course, because it's really difficult and challenging to go through this kind of exercise in just 45 minutes. It would actually need more like 1.5 hours, and we don't have that time. So let's just now start with some of the tests. So now with test, I just say that if I roll a 0, then I have the score of 0. So let's try to run the test itself with the original implementation. And let's see if the first few test cases will pass. So if I roll a 1, then I have a score of 1. And here comes the next one, which will be a full game. If I roll for the 20 rolls for actually the 10 frames, one pin, I hit down one pin on each roll, then I should have the score of 20. Actually, all of these will be working fine. I have the first problem when I try to evaluate my first invariant, which is that I should have no more pins than what's possible in the first frame. So if you remember, and let me just quickly just jump out from the presentation and go back here and try to just draw on the screen. So this means that I have this kind of first frame here. Then I have the score of 7 here at the first try. Then I have the score of 7 here in the next try. This is of course not possible because the maximum number of pins that we have is 10. And I just define my test that it should throw this kind of illegal roll exception, which should be part of my bowling package. Unfortunately, this one fails, of course, if I have this primitive representation. Now, instead of putting this code here in the test, I will just go ahead and try to do it with more sophisticated way by first writing test for the intermediate frame. Okay, so again, I have the test cases prepared just to speed up things, but I don't have the actual implementation ready. So you can see that the first test will actually fail. And in TDD, basically you just write test first, try to define the interface and the desired results that you would like to get after the end when you are interacting with your classes. And what I did first is just filled in some of the tests ahead. So when I have a frame, I want to roll the number of pins for the first and the second time, and I should get the results of the first and second roll. So this exactly immediately defines that each frame has 2 rolls actually, so each frame, excluding the 10th frame, can just hold 2 rolls. So let's now see the implementation itself, because the test will fail, and I just go to the intermediate frame, try to capture this logic in the method body. So if I have the first try, okay, then I have to do something. I will create an int for tries. I will create a constant for the first try. This will be 0. And I have to then set the first row. I have also this kind of structure here that you've seen here represented, with the exception that I added an additional base frame class above the or below the frame interface, which has some basic kind of helper methods that I don't need to implement, like first row, second row, the setters for the first and second row. If I go to the second try, I have to set the second row. That's what I define now. This will be this case. Second row pins. And on each round, we just increment the number of tries. We now go back to the, oh, what did I read wrong? We should, of course, this is not fine. We should now go back to the test itself. I just passed the first test. So I go ahead and check what should happen when I have 3 rows in the frame. If this is an intermediate frame, this should not be available. So I define here a new exception called no more rows exception. This should fail again, so I go to the intermediate frame and have, again, helper method. I will talk about that. Check if the try is greater than the maximum tries, which is going to be 2. This will add an exception. Now that my test will pass, and you can see that this is just a simple comparison. So if I compare the tries to the maximum, then I should throw a no more rows exception. This is part of the base frame. Okay, now going back to the test itself again. If I roll with 10 pins, then I should have the score of 10. So this will be actually the first section when I implement the score. It should get me the first row, the second row as a sum. Let's see if it's enough for now. Yeah, it looks like it's enough. Okay. Now this is similar to what you see in the game test. I cannot have the score of 14 in the first frame because the maximum number of pins. This is actually another kind of invariant that I need to capture in the intermediate frame. And just go back to the intermediate frame and have another verification of number of pins. This should be less than the maximum. And this should be the sum of the first row plus the pins that now rolled. Because if we are having the first row, then this will be 0, or this will be actually the amount of first row. This will be 0, of course. If you have the second row, then this will be the amount of first row, and this will be the currently hit number of pins, like in this test case. Let's run all the tests. Just first test. Now we try to do a spare calculation. This will be improving the score evaluation. So if I have a next frame, I should have a setter method for the next frame, and I have then the score of a spare, which is 10 pins. The first frame, and the next frame has the score of 2, then this will be the sum of score of 12. And I need to have the help of the next frame for that. So let's now go ahead to the intermediate frame. I have the set next method already prepared for this one, but unimplemented. So I just create a frame for that, or a field for that. And now I try to use this in the score. So the frame score will be sum of the first and the second row. And actually, I need to make null check first, which will be this has next method. And if I have has next, then if I have a next defined, then if I have a spare, then I give back frame score plus the first row from the next frame. So actually, I just define the requirement as it's usually written. Of course, I need the has next to be implemented. So we just return null check. We can fix this later if we have time for that. Before we return the frame score. And our test will pass. We can now try to negate the method implementation. Just to have some kind of guard clause here, a little bit of refactoring before we move forward. Then we have multiple return values, whichever prefer exactly. So pros and cons on that. Let's now continue with strikes. So I have scored 10 for the first try in the first frame, and I have the next frame, and I have now 2 rows here, a 2 and a 5. That should give me the actual maximum score of 17 because I received some bonuses. This fails now, so I go to the intermediate frame and say that if this is a strike, I want it to behave differently. So in this case, I just return the frame score plus next first row plus the next second row as a bonus. I have the strike implementation. So we go forward. So even if I have the strike, see, for the first frame, but the next frame does not have any score, it might just make sense to have some kind of intermediate value for the frame itself. So I write a test for that. Fortunately, I don't have to do any other implementation for that. Okay, now I say that we are quite okay with the intermediate frame implementation. So let's go ahead with and capture the rules for the 10th frame. It will be quite similar. So what's with the first test? This should not pass. Probably I just run wrong set of tests. 10th frame test should be the 10th frame test. It's going to fail. I go back to the 10th frame. I have to do the same implementation here. So it's quite similar. Let's now try to first now fake it. I will just go ahead here and copy over the implementation, copy over the these kind of constants. Just again to try to speed up things. Let's see how much time does it save for us. Now we can even refactor later when we will have more time, or when all the tests will be now green and everything will be in place. So we just passed the first test case. Now what should happen when we have again 3 rows? Try to do 3 rows, but does not have a strike or a spare. For a 10th frame, this shouldn't be allowed. So we need a similar implementation here as before. Should be no more rows exception. So again, tries, we compare this with maximum tries. We need to improve that for these kind of special cases. But now the test will pass. What if we have a spare? Now we have a spare. Maybe I should draw this one because things are getting a bit more complicated. So in a 10th frame, remember we have these small 3 boxes. I have the score of 3 here, and I have a score of 7, which will be this kind of triangle. This gives me back the score of 10, so I now have a chance to go here and score a 2. But then another 2 is not allowed, so that's what the test is trying to describe. Go back to the test, to the implementation itself. So I can write here a get number of tries method that tries to evaluate the number of tries. What's the implementation of this method? I give back the maximum tries in normal cases, but if this is a strike or a spare, then I will give back maximum tries plus 1. So I have additional try to go. I cannot have more than 3 tries, so I cannot return more than 3 for sure. But if I hit a strike or a spare, I have now additional option to go. So this is various for the 10th frame. If you look at the strike and spare implementation, maybe I haven't shown that, you can see that it's just simply saying that, okay, it's again the implementation given in the base frame that, okay, if the first roll is 10, then first roll is 10 and this is a strike. If the sum of the first and second row is 10, then this is a spare. Simple implementation that I can rely on. Okay, now going back to the 10th frame, let's see if the test is going to pass. Now the same goes for strike. So I have a strike, so I have now 2 rows to go, 2 additional rows to go. We implemented already this one. Awesome. Now what happens if I have 10 pins? Have the score of 10. So this will be the first core implementation actually for 10th frame because we don't have this in place. Let's try to give back again similar things as for the intermediate frame for the first time. Let's see how much it will be enough, or how many times it will be enough. So here comes another invariant. So if I have scored 9 and I try to score again 2, so if I don't have a strike and a spare, this should not be allowed. How to reflect this? Here. I need to write this verify number of pins is less than maximum. Let's try again to use the same here as in the intermediate frame. It's true for cases when I don't have a spare, but you can see that I have a failure immediately, a regression, when I have a strike, because in this case, if I have a strike, I can score more. So what's the solution for this one? And I need to go to the 10th frame, sorry, not to the intermediate frame. So I will just extract this method and say that is third roll allowed. So the third, I missed the D, third roll allowed whenever I have a strike and a spare. And I want to reuse this method and say that if the third roll is not allowed, then this is true. And I need to have the number of pins be less than maximum for the first and the second row. but not necessarily true if I have a third row. This is going to pass. I go ahead. So what happens if I have, oh, sorry. If I have a spare, in this case again, I can have the third row, and then I have the score of 12. So this is again an implementation improvement for the score evaluation. This is going to fail because what I forgot to do is I forgot to add the value of the third row, which is not saved here. So I need a value here called third row, which is going to be a field, which will be saved when tries third row. Like that. I need a constant for third row. This is going to be, oh, sorry, third try. Let's try to make the convention the same all over. Okay. Let's now see if the test is going to pass. I have problems with the spare itself. I need to go back. Okay, let's start everything from all over. I have the 10th frame test. I need to fix the score here, probably. Need to add the third row, which is probably not added. Yeah. It's getting late, probably that's why. It should be 2. I have 4 tries. It should also pass, so I have the maximum score of, I don't allow actually 4 tries, never, even when I have a spare here. If I have the strike, again, this is a score calculation, evaluation. I should have a bonus of 2. And then if I have a strike and try to cheat and try to add the score of 12, it should not be allowed. And actually, this is what is missed, but it's hard to capture, because if the third row is not allowed, we have to still evaluate the maximum number of pins for just the pins. This will be the whole implementation for the 10th frame. When we have 3 strikes, then we have the point of 30, and so on and so forth. So now we are doing quite good. Let's now try to make the change in the game test itself and try to implement the game itself with the usage of frames. So let's now start the game test again from here. It should first throw an illegal role exception. I just go into the game, and now I have frames, things called frames, which will actually have 10 frames instead of this 21, which was quite a strange number. I need a constructor for that. This can be final. Okay. Okay. But yeah, no args constructor. And this will create frames. First create the intermediate frame, then from 1 to 8, I should the new frame, which is going to be an intermediate frame for the given index, of course. So I just need to add here a new method, which will add the new frame to the given index. And actually, this is a frame and a frame itself. Why do I need that? Because I should make two operations here. For the frames at index will be the new frame, but actually for the previous index, I should have, sorry, frames index -1. I should have a set next configured for the frame itself again. And at the end, I just add the new frame for the index 9, which will be the new 10th frame. Okay. The score calculation will be changed, or the roll calculation. I should just delegate this to the roll method here, which will now throw the exceptions, and the score will be also changed. Score calculation. I should have a map to int for frame score and then sum up the results. So actually, you can see that game is now just is responsible for its own invariants. I just hold the invariant of having 10 frame. Everything else is quite just delegated downside to the frame itself. And this simplifies the actual game implementation. So when I go back to the game test, let's see if now things pass. We have an issue, a lot of issue actually. Some of the tests will be quite good, so some of the tests will still pass. And actually this one is also, I think, will pass, no? Nothing was thrown. So this is strange. We have to go back to the game implementation and see what's going on. Yeah, I should not increment the turn always. I just should increment the turn when I know that there are no more rows that can be held in the actual frame itself. So how I can actually describe this? So if frames turn no more rows, then I go to the next turn. Okay. Now this is again something that is represented here in the interface, but I was not implementing that. So I just go ahead and the test itself, I have the test for that. So first it should be false. So return tries equals to maximum tries. First, this is a good guess, I guess. When I have a without strike and spare, it works fine. But as soon as I have a spare, or as soon as I have a strike, this is not going to work. So instead of writing that, I should go back to the intermediate frame and return. If this is a strike, then I have no more rows, of course, because I have no more option to go. I have to just proceed with the next frame. If I don't have a strike, then I just go with the maximum number of tries. Now, if we go to the 10th frame test, I have also this one implemented with the tests. Now, because we are getting out of time, and we just proceed and try to explain how it should work for the 10th frame quickly, because we can try again to just copy over the implementation, isn't it? It should be somewhat fine. Let's go and first go with this one. This here's the 10th frame, so no more rows is not implemented. I return if the tries is equal to the maximum number of tries and see what happens. See if how many tests are going to pass. With strikes and with spares, this is not true because this is variable. So if I now go to the method instead that we defined for getting the number of tries, everything should be fine and good. So getting back to the game test and really now assembling the whole game test. Sorry. I can see now that most of the tests will pass. So actually, by structuring the game fine, I was able to match all these invariants, except one thing, which is what happens if I have all the strikes. So in this case, again, I have to draw for this one to be able to understood, because it was so complicated to reveal actually. This is what happens. I have the strike here in the first frame. I just scored 10. Actually, I should not really write here anything, just have a full box. Here I did. Then in the next frame, so this is this game row 10. This is the first frame. Next frame, I have again a full box here, again a strike. So I have 10 points here, I have 10 points here, and I have 10 points here. Now the bonus for this round should be 10 plus the bonus of the next two rows, which should be then meaning that I should go for the next frame, and for the other frame, the two frames, that's two frames ahead. So this frame, the next frame actually should detect when the second row is 0, or even if it was a strike, and again go forward with an additional frame to get the score of 10. So this gives max the sum of the score for this one with bonuses, which is 10 plus 10 plus 10. This will be 30. 30 here. The other one should be 10 plus 10 for the next round, 20, because I don't have a third or fourth frame, and the other one is 10. So that's why the that says 60 in this case, which is 30 plus 30. I hope you were able to follow that. And for this one, actually, this one won't pass. So I will now just try to speed up things and do this at once. So for this one, I need to change the implementation of the intermediate frame. Here is the problem. So the next get second row is not guaranteed to be set. So I should use a special method, which will be this get second row for bonus. This is implemented in the interface. And for the intermediate frame, this should return. If I'm a strike, as I said before, I should return the first row from the next frame, actually, which is the third frame now. Or I should return my second row. I hope it won't pass for the first time because, okay, because we just work with intermediate frame. We don't have the implementation with the 10th frame. So now let's just go with the perfect game. But I have a perfect game with the score of 300. Let's go ahead and on the tests. I get an unsupported operation exception. You can see from the 10th frame, I don't have this method implemented. So in the 10th frame, we don't have this special rule. So I will just return the second row. Run the test. Test passed. And now run the real example, which will be identical with what you see in here. All these scores are now mapped to these kind of small boxes. I should have the total amount of 133 as a score. This one is also going to pass. So this actually concludes our exercise, and I have to wrap up, unfortunately, because also time's up. So what I want to say at the end is just thank you very much for being with me. If you have any kind of questions, you can reach out to me by using the links that is shown. Also, I have coding stories example as a link and similar ending that you can experiment with. And you can start from scratch. I also have a project configured for you. If you follow the link, you can also investigate that. So thank you for joining me, and thank you very much.
Thank you, Oresztesz. It was a great like TDD session. I never thought I would be able to follow it, but and I didn't, but I know everything about bowling. So thank you very much. And I'm turning virtually to the audience. We have almost 30 people. Are there any questions? please feel free to put it down the chat. And while you collect your courage, just a kind reminder, this recording will be available in the coming days on our channel on YouTube and on the social media as well. Well, unfortunately or luckily, I don't see any questions. So thanks again, Oresztesz, for this great presentation, and thanks all the audience for coming. Goodbye.
Thank you. Bye-bye.